talking about some examples. So we're looking at number 15. So number 15, we're going to look at what would happen if we have y prime minus 2y equals 7 times sine of 4x. Okay, something like that. So times 7 sine of 4x. Well, we have to look at our particular solution, our complementary solution, and we're going to have our complementary solution will just be c1 e to the 2x. There's not really anything interesting. This is actually a first order differential equation, so we could actually solve this using this is actually a first order linear differential equation. So if you want, you could multiply, what would we have to do here? You'd have to find the integrating factor mu, and then multiply both sides by mu, and then see how that works. That would give you a integration by parts integral on the right, but that's totally reasonable. So you could actually do it that way if you like. But alternatively, you could think of this as a first order linear non-homogeneous equation, and then use this method of superposition. So our complementary solution is going to be c1 e to the 2x, and that means that we're going to have our, I know that this is a little bit silly, but our characteristic equation of the associated homogeneous equation, there's so many words, is r minus 2 equals 0. So of course the solution will be r equals 2, but it's r minus 2 to the first, right? So we have a solution of multiplicity 1. And therefore our particular solution is going to be a constant times sine of 4x plus another constant times cosine of 4x. So you have to keep those angles the same inside your sine and cosine terms. Okay, so that would be your particular solution there. So let's say we wanted to find y prime minus 2y equals something like 7x squared sine of 5x. Okay, something like that. What we would need to do to find the particular solution is, first of all, we're not going to have any repeated roots here. We have a sine of 5x term appearing. That would be in the complementary solution if we had something like plus or minus 5i appearing as our root. We don't have that, so we don't have to worry about multiplying by any powers of x in front. All we have to do is think about what's the general form going to be here. And so if we have a quadratic times sine of 5x, then probably what we'll do is we'll need to do something like ax squared plus bx plus c times sine of 5x plus maybe another constant, let's call it dx squared plus ex plus f cosine of 5x. And again, both of those terms will need to be in there. Whenever you have a sine term, you should also put in that corresponding cosine term. I should mention, by the way, that thinking of this as a linear differential equation in this case is going to be easier, because if you were to multiply both sides by, I think the integrating factor would be, let's see, 1 over x, something like that. And so you'd still have this integration by parts to do. So it might be easier just to do it this way. It might be easier to do it by parts. But you have some options now anyways. So this would be your general form there. All right, and so what if we were to have y prime minus 2y equals, let's look at something like e to the 4x cosine of 3x. How would we deal with something like this? So we have e to the 4x cosine of 3x. Well, what we could do is we could think about what would this e to the 4x cosine of 3x should remind you of when you have complex solutions, and your solutions were something like 4 plus or minus 3i, right? That's where you would get an e to the 4x cosine of 3x or e to the 4x sine of 3x. And so your particular solution is going to be very similar. You're going to have an e to the 4x times a cosine of 3x plus b sine of 3x. And it turns out that's going to be the right guess for the particular solution there. And now let's look at what happens if we were to have y prime minus 2y equals, let's say we were to have two trig functions there. Let's say we were to have e to the 3x times cosine of x plus sine of 8x. Well, what we would have to do is, again, r equals 2 is not going to be, the fact that 2 is our solution to the characteristic equation does not actually matter when we're finding the particular solution, and so we don't really have to think about that too much. Our particular solution then would be, let's see, e to the 3x times a cosine of x plus b sine of x. That's how we would handle this term, the e to the 3x cosine of x. And then the sine of 8x would be if we were to have something like c sine of 8x plus d cosine of 8x. So we would need both of those terms in there. And in fact, that principle is true in general. If you were to have, let's do this. If you were to have y double prime minus, let's look at minus 16y equals, let's look at e to the 5x plus sine of 2x, then your particular solution would be a e to the 5x plus, if you have sine of 2x, then you're going to need a sine and a cosine. So it would be b sine of 2x plus c cosine of 2x. So you'd need both terms in there. And a little bit more general than that, if you were to have y double prime minus 16y equals, let's say we were to have x cubed e to the 5x plus x e to the 4x plus sine of x. Okay, so let's say that that's the equation that we would need to find. This one is incredibly mean. I wouldn't actually ever do this and expect you to find all the values, but in principle we could figure out what the shape of the particular solution is going to look like. So the x cubed e to the 5x is just going to be a general cubic. So ax cubed plus bx squared plus cx plus d times e to the 5x. And that's because 5 is not a root to the characteristic equation of the associated homogeneous equation. On the other hand, 4 is a root. So here we have a linear term. So we're going to have we'll call it ex plus f e to the 4x. But 4 was a root to the characteristic equation, and it was a root of multiplicity 1, so we put an x to the 1 in front. And then to deal with the sine and cosine terms, we would have, let's see, we would have, what letter were we at here? G sine of x plus h cosine of x. And that's how that one would work out. And then if we were to have, I think it's also worth talking about something like this. If we were to have y double prime minus 4y prime plus 5y equals, let's see, whatever the right side is, the characteristic equation of the associated homogeneous equation would be r squared minus 4r plus 5 equals 0. So that's going to be r is 2 plus or minus I. And so if we were to have something like e to the 2x cosine of x is the non-homogeneous function, the function on the right-hand side of the equation that makes us non-homogeneous. For our particular solution, what we would do is we would just look at e to the 2x cosine of x. So we would have e to the 2x times a cosine x plus b sine x, and that's going to be there whether or not we have repeated, whether or not this represents some solution to the characteristic equation that's been repeated. Here, notice that 2 plus I and 2 minus I are two solutions, but they're both of multiplicity 1, and that means that we have to put an x in front. Okay, so again, we have an x to the first because they're solutions of multiplicity 1, and that's how that works out. So this is the general process. If you were to have, let's just keep going and let's look at just a few more. If you were to have, say, y double prime plus 9y equals x squared sine of x. X squared sine of 3x. Okay, this is about as complicated as I can think to make it. What you would have for your general solution would be, let's see. So notice that sine of 3x appears in the complementary solution because plus or minus 3i are your solutions to the characteristic equation. And so your particular solution is going to end up being, let's see, ax squared plus bx plus c cosine of 3x plus dx squared plus ex plus f sine of 3x. All of that is times x, because plus or minus 3i are both roots of multiplicity 1. So we'd need an x to the 1 in front. Okay, and that's how that goes. In the next video, let's talk about higher order analogs of this problem.